I'm going to start off by saying the most obvious thing ever. So, at school, each grade prepares you for the following grade. So, for instance, in mathematics, the stuff that we learn in grade 8 prepares you to be applied in grade 9, while you are learning new stuff to apply it in grade 10 and so forth and so forth. So it is important to always try not to forget stuff from the previous grade because they are mostly applicable to the following grade. For instance, in grade 1, we learned that 1 plus 1 is equals to 2. Even by the moment you get to grade 12, 1 plus 1 still remains 2. But now they've added variables, they've added exponents, but then still the same concept. Our question today was selected from a grade 12 question paper. Here is the question here. Without wasting time, let me just go through the question and then we're going to analyze everything together as we go by. So the question reads, during an experiment, the temperature T, which is measured in degrees Celsius, varies with time T, which is measured in hours. According to the formula, so there is our given formula. T to the T is equals to 30 plus 4T minus 1 over 2T squared. Given that it's on the interval of between 0, T is between 0 and 10. So I've seen that normally students, they ignore the interval part. The interval part is as important as the equation itself because it gives you some limitations such that T doesn't exceed anything below 0 and it doesn't exceed anything above 10. So it's between 0 and 10. Very much important. And then 8.1, we are required to determine an expression for the rate of change of temperature with time. At some point, you learn how to differentiate. So differentiation can mean a whole lot of things. Remember, mathematics is applicable in mathematics itself as a subject, in physics, in economics. Actually, mathematics is just one of the skeletal things whereby it's used for calculations in various subjects like that. But differentiation can mean a whole lot of things. So now, for 8.1, for us to determine the expression of rate of change, the moment they consider rate of change, it means rate of change comes from differentiating the actual formula. So for us to get 8.1, we just have to differentiate our given equation as it is here. Let me show you how it's done. So again, we are given that this is the formula and the interval of the formula is between 0 and 10. Like this is the same as us saying T is between, this is the same as us saying T is greater than 0 but less than 10. So it's between 0 and 10. This means the same thing, by the way. And now that we're going to differentiate, I just want everyone to remember that if we want to differentiate T, for instance, given that T is to the exponent n, the differential of T would be then such that T will subtract 1 from n and then we'll multiply by the coefficient of T as well. This is the whole point of differentiation. I hope everyone still remembers that. So now 8.1, I have to show the expression of this formula for rate of change. And I said rate of change is the same as me differentiating. So to differentiate this, I would have T prime, small letter t, is equals to, I can just remove this for now. The differential of a constant number is 0 plus. So I know that there's 1 here, t is to the exponent 1. So if I apply differentiation here, I would have 4 times 1 into t1 minus 1 minus 1 over 2. So now this is exponent 2, 1 over 2 times 2 into t2 minus 1. That is me differentiating, and then I can simplify this. Simplifying this would have 0 is 0, 4 times 1, t. 1 minus 1 would give me 4 to the exponent 0. T to the exponent 0. Minus 1 over 2 times 2. This is the same as 1 over 2 times 2 is going to be 2 over 2, which is just going to be 1. So I'll have minus t into the exponent 2 minus 1, 2 minus 1, which is just going to be 1. Hence, if I simplify this, I'll have 4, because any number to the exponent 0 is just 1. So it's 4 times 1, which is just going to be 4 minus t. So this is the expression of rate of change of temperature of this formula. That's how we answer 8.1. So for 8.2 now, we are required to show during which time interval was the temperature decreasing. Just like that, you are just expected to use the information you have to give the interval when the temperature was decreasing. Again, like I say, differentiation can be used in various forms. So now, to tell the interval of when the temperature was decreasing, you just have to show that the rate of change, it decreases at, this is how it goes. However, we know that our rate of change is 4 minus t. Therefore, for 8.2, temperature decreases when the rate of change is less or equals to 0. That's what we represent for decreasing temperature. And then now I have to solve for t when the rate of change is decreasing. And I know that my rate of change is 4 minus t is less than 0. Solving for t here, I'll have minus t, it's less or equals to minus 4 if I take the 4 to the other side. But now I have to divide by -1 because I'm solving for t, right? If I divide by -1 both sides, I'll have that t is greater or equals to 4, because whenever you are dividing by a negative in inequalities, the sign changes and faces the other direction if you divide by a negative. So now it means then we can safely say t, when t was greater than 4, that's when the temperature was decreasing. But before you conclude this as your final answer, remember that you have the interval that was given initially. We are told that t is between 0 and 10. And I did state that this is the same as us saying t is between 10 and 0. Now, it's decreasing when t is greater than 4. Considering what I have, let me just put it on a number line. So our given interval is that t is between 0 and 10, right? And we are told that by definition, that's where our solution, that's where the equation goes. It goes like that. But somehow here, when t is 4, that's when the temperature is decreasing. When t is 4, that's when the temperature is decreasing. So to get the solution, it means through anywhere where t was greater than 4, throughout until the given interval, that's when the temperature was decreasing, which according to our limit, it shouldn't exceed 10 anyway, but it's anything above 4. Therefore, my final answer would be that the temperature was decreasing between 10 and 4 hours. So this is our solution. So you may fall for it thinking this is the final answer. No, you have to consider the interval that was given, because still, if I put it like this and say t is greater than 4, it means I'm saying it's greater than 4 going throughout, meaning 4, 5, 6, 7, 8, 9, 10, 11, 12, up to infinity. But because I'm given from the formula that the temperature doesn't exceed 10 hours, I have to show that anything greater than 4 but less than 10, the temperature was decreasing. Hence, this would be my final answer for question 8.2. So the secret is to make sure you read and understand the question clear and consider the intervals that are given in all cases. Don't ever think that a part of information on a question, it doesn't add value to the question itself, because had we exceeded the interval of between 0 and 10 here, we would have gotten the whole thing wrong. I'm Mr. My Money. This is Simplified RSA, where the guys makes it looks easy. Please make sure you subscribe to our YouTube channel. Press the reminder button such that whenever we put videos like this, you'll always be notified, and follow us in all our social media platforms. Also, we do offer private lessons such that if you want us to have a one-on-one, you can send us an email on this number here. On this email address here, or you can contact us in any other form, or WhatsApp message or whatsoever. Otherwise, until in the next